Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. This video, as you have probably noticed, will be a bit different than my other lab videos in the course. We didn't actually cover any configurations in the lecture video, so there won't be a packet tracer practice lab file for you to practice with. Instead, I will just give you a quick demo in EVE-NG, a network simulator, of one kind of network attack that I mentioned in the lecture video. Then, in the next lecture video, we will see how to configure a Cisco switch to prevent this kind of attack. The attack I will show you is the DHCP exhaustion attack, also called DHCP starvation attack. In this attack, the attacker sends countless DHCP discover messages, and then any DHCP servers on the network will send offer messages. After the server sends the DHCP offer, the IP address it offers is reserved while it waits for a response from the client. So, by sending tons of discover messages, the attacker uses up all of the IP addresses in the DHCP pool, and other hosts on the network will not be able to get an IP address. To demonstrate that, I will connect PC1 to the network, and we'll see if it can get an address via DHCP. In this network, R1 is the DHCP server. The attacker is this PC here, running a Linux distribution called Kali Linux. Kali Linux is popular in the world of cybersecurity, penetration testing, and such. It comes with various pre-installed tools for digital forensics and penetration testing, and we will be using one called Yersinia for the DHCP exhaustion attack. First, let's open the CLI of R1 to take a look at the DHCP settings. Enable Show Run Section DHCP. Okay, so here's the DHCP pool, 192.168.1.0/24, and it will tell hosts to use R1's own IP address, 192.168.1.1, as the default gateway. The DNS server is 8.8.8.8, Google's DNS server. This IP address DHCP at the bottom isn't actually part of the DHCP pool. It's from R1's G01 interface settings, but it was included in the output of show run section DHCP. Now let's use some other show commands. Show IP DHCP pool. As you can see in pool 1, there are 254 available addresses. I didn't configure any excluded addresses. Note that R1 won't assign its own IP address, 192.168.1.1, to another host. So really there are 253 available addresses that can be assigned. However, currently there are 0 leased addresses. And if I use the command show IP DHCP binding, we can see that there are currently no entries. So let's go into the Kali Linux box. I already have the terminal open, so let's open Yersinia. The command is Yersinia-G. So this opens the GUI, graphical user interface of Yersinia. To launch our attack, I'll click on Launch Attack. Then select DHCP, and there are a few DHCP attacks we can do. In this case, I want to select Sending Discover Packet. As the check mark indicates here, this will cause a DOS, denial of service. Then I simply click OK, and the attack has started. On the right, you can see each DHCP discover message being sent. And here on the left, you can see the DHCP packet count rapidly rising. Unless I tell the attacker to stop, it will continue sending these discover messages. So let's see what's happening on R1. First, let's check the pool again. Show IP DHCP pool. Okay, of the 254 total addresses, 253 are being leased. And as I said, one is used by R1 itself, so that means the entire pool is being used. Let's check the binding table. Show IP DHCP binding. Okay, I'm just going to keep pressing the spacebar as R1 goes through the DHCP binding table. You'll see that every address, from 192.168.1.2 to 192.168.1.254 is currently taken. Also notice that each of these IP addresses has a unique MAC address. That's because the attacker is spoofing the source MAC address used for each discover message. So R1 thinks that each of the messages is coming from a different host. Okay, let's see if PC1 is able to get an IP address. Before connecting it to the network, I'll check some settings on PC1. Here in the command prompt, let's check ipconfig/all. Okay, here under the Ethernet adapter, we can see media disconnected because it's currently not connected to the network. And we can see DHCP enabled yes. So once we connect PC1 to switch 1, it should try to get an IP address via DHCP. Let's see if it works. So I'll click here on PC1 and connect it to switch 1. PC1's interface is E0 and switch 1's is G01. So I'll just click on save. Now let's check on PC1 again. From the command prompt, ipconfig/all. Okay, under the Ethernet adapter, we can once again see DHCP enabled yes. It has a link local IPv6 address, automatically generated. And below that, we see an IPv4 address. So did DHCP work? Actually, no it didn't. As it says here, this is an auto-configured IPv4 address. PC1 generated it automatically. It has the prefix 169.254/16. The subnet mask is 255.255.0.0. 169.254.0.0/16 is the IPv4 link local address range, so it functions like the IPv6 link local address above. So PC1 auto-generated IPv4 and IPv6 link local addresses, but it wasn't able to get a regular IPv4 address from the DHCP server R1. So, PC1 won't be able to communicate with any other devices on the network. If I try to ping R1, for example, ping 192.168.1.1, as you can see, it doesn't work. What if I try to renew the IP address? ipconfig/renew. So, PC1 will once again try to get an IPv4 address via DHCP, but once again, it won't work. We could wait here for a while, so I'll just use Ctrl+C to stop it. Next, I'll delete the connection from the attacker to switch 1 by clicking here and selecting Delete. Next, I'll go on to R1 and clear the DHCP bindings. I taught you this command in the DHCP video. The command is clear IP DHCP binding, followed by an asterisk. Okay, now I'll go back on PC1 and try to get an IP address once more. ipconfig/renew. This time, R1 should have an available IP address for PC1 now that the attack has stopped. And indeed, PC1 was able to get an IP address. So let's test if it can use the internet. I'll open Firefox and go to google.com. Okay, PC1 is now able to access the internet. So, in this video, we took a look at one kind of network attack, the DHCP exhaustion attack. Although there is no packet tracer lab file for you to practice with this time, I hope it was at least interesting to see. In the next video, we'll look at a Cisco switch feature called port security, which can be used to prevent this kind of attack, as well as others. Okay, that's all for this lab. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to C-Mode, Scott, Martin, Kwa, Justin, Christopher, Tebogo, Anand, Pavel, Abraham, Sergey, Njoku, Victor, Roger, Raj, Kenneth, Seamus, Brandon, Marcel, Coney, Donald, Gustavo, Prakash, Nasir, Erlison, Marco, Daming, Ed, John, Funny Dart, Velva Jacob, Mark, Yusuf, Boson Software, Devin, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, May 13th, 2021. If you signed up recently and your name isn't on here, don't worry. you'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.